సబ్స్క్రైబ్ చేయండి. ఫర్ మోర్ అప్డేట్స్ బెల్ ఐకాన్ క్లిక్ చేయండి.
Now we are going to discuss dielectric strength and loss. What is the dielectric strength? Dielectric strength means is the strength that defined as the maximum electric field can maintain without electric breakdown. The dielectric strength means the dielectric strength of a dielectric defined as the maximum electric field that it can maintain without breakdown. అంటే ఎలక్ట్రిక్ బ్రేక్డౌన్ లేకుండా, వోల్టేజీలో ఎలాంటి బ్రేక్డౌన్ లేకుండా మ్యాక్సిమం ఎలక్ట్రిక్ ఫీల్డ్ని ఇండ్యూస్ చేస్తే, మ్యాక్సిమం ఎలక్ట్రిక్ ఫీల్డ్ ఇండ్యూస్ అయితే, అంటే వోల్టేజీలో ఎలాంటి బ్రేక్డౌన్ లేకుండా గరిష్ట విద్యుత్ క్షేత్ర తీవ్రతను పొందగలిగితే దానిని డైఎలక్ట్రిక్ స్ట్రెంత్ అంటాం. సో ద డైఎలక్ట్రిక్ స్ట్రెంత్ ఆఫ్ ఏ డైఎలక్ట్రిక్ ఈజ్ డిఫైన్డ్ యాజ్ ద maximum electric field that it can maintain without electric breakdown. ఎలక్ట్రిక్ బ్రేక్డౌన్ లేకుండా మ్యాక్సిమం ఎలక్ట్రిక్ ఫీల్డ్ని ఇండ్యూస్ చేయగలిగితే కనుక దానిని డైఎలక్ట్రిక్ స్ట్రెంత్ అంటాం. ఇట్స్ ఆల్సో కెన్ బి డిఫైన్డ్ యాజ్ ఆర్ maximum value of electric field intensity. Maximum value of electric field intensity, that means విద్యుత్ క్షేత్ర తీవ్రత, electric field intensity or electric field is similar words. The maximum value of electric field intensity that a dielectric can withstand without breakdown is called as a dielectric strength. అంటే maximum electric field intensity ఉండగలిగితే, ఏమి లేకుండా బ్రేక్డౌన్ లేకుండా ఉండగలిగితే దానిని డైఎలక్ట్రిక్ స్ట్రెంత్ అంటాం. ఈ రెండు కూడా డెఫినేషన్స్. డైఎలక్ట్రిక్ స్ట్రెంత్ ఆఫ్ ఏ డైఎలక్ట్రిక్ ఈజ్ డిఫైన్డ్ యాజ్ ద maximum electric field that it can maintain without breakdown. Other hand, maximum value of electric field intensity that a dielectric can withstand without breakdown is called as a dielectric strength. This is the dielectric strength. By the reason of this property, the dielectric behaves a insulator or conductor. That means dielectric means the dielectric behaves insulator or conductor, but these two type properties are behaves the dielectric by the reason of strength. So by the reason of dielectric strength, every dielectric behaves a insulator or conductor. And also the dielectric strength depends on the thickness of insulating material. By the thickness of insulating material. So the dielectric strength, so small thickness, heavy thickness, large thickness, total heavy thickness. So the dielectric strength depends on the thickness of the insulating material or and also electric field. The dielectric strength is very important property in the design of high voltage generators and motors, transformers. Okay, the dielectric strength is very important property in the design of high voltage motors and high voltage generators and high voltage transformers. Generators, motors, transformers, high voltage. Dielectric loss. The dielectric loss may be defined as the loss. Of energy. So the dielectric loss means loss of energy in the form of heat. By dielectric medium due to internal friction developed in switching of dipoles to their normal state under the action of charging and discharging under AC conditions. First of all, the dielectric loss may be defined as the loss of energy. Loss of energy in the form of heat. In the form of heat in the dielectric medium due to internal friction. Developed the switching of dipoles. So the dielectric loss may be defined as the loss. The dielectric loss is the loss of energy in the form of heat due to internal friction developed in switching dipole to their normal state under the action of charging and discharging under AC conditions. This is the definition of dielectric loss. The dielectric loss, once again, the dielectric loss may be defined as the loss of energy in the form of heat by a dielectric medium due to internal friction developed in the switching of dipoles to their normal state under the action of charging and discharging under AC conditions. So once again, so the dielectric loss is the loss of energy in the form of heat. In the form of heat, okay, by dielectric medium. By dielectric medium in the due to internal friction. Internal friction. So the dielectric loss is the loss of energy in the form of heat by dielectric medium due to internal friction under the conditions AC power conditions. So due to internal friction, the dipoles are switching. So ఇప్పుడు చూడండి, డైఎలక్ట్రిక్ లాస్ అనేది ఎనర్జీ లాస్, శక్తి నష్టం. లాస్ అనేది ఎనర్జీ లాస్. అది ఏ రూపంలో ఉంది? హీట్ రూపంలో ఉంటుంది. దేనివల్ల జరుగుతుంది? డైఎలక్ట్రిక్ మీడియంలో ఇంటర్నల్ ఫ్రిక్షన్ ద్వారా జరుగుతుంది. ఆ ఇంటర్నల్ ఫ్రిక్షన్ ద్వారా ఏమవుతాయి? డైపోల్స్ అనేవి మారుతూ ఉంటాయి. ఈ మొత్తం కండిషన్ ఏంటి? ఏసీ కండిషన్. అంటే ఏసీ కండిషన్లో విద్యుత్ క్షేత్రాన్ని డైఎలక్ట్రిక్ మీడియం మీద అప్లై చేసినప్పుడు హీట్ రూపంలో లాస్ ఆఫ్ ఎనర్జీ అనేది డెవలప్ అవుతుంది. ఎందుకు ఏర్పడుతుందంటే డైఎలక్ట్రిక్ మీడియంలో ఇంటర్నల్ ఫ్రిక్షన్ వల్ల, అంతర్గతంగా జరిగే ఘర్షణ వల్ల డైపోల్స్ అనేవి ఏర్పడతాయి. అంటే డైఎలక్ట్రిక్ లాస్ అంటే ఏంటంటే, ఏసీ విద్యుత్తును అనువర్తింపచేసినప్పుడు డైఎలక్ట్రిక్ మీడియంలో హీట్ రూపంలో ఎనర్జీలో లాస్ ఏర్పడితే దాన్ని డైఎలక్ట్రిక్ లాస్ అంటాం. సో నౌ ద డెఫినేషన్ ఈజ్ the dielectric loss is defined as the loss of energy in the form of heat by dielectric medium due to internal friction develops the dipoles under AC condition. This is the dielectric loss. Now we have to derive the energy loss, dielectric energy loss, equation of the dielectric loss. So consider the equivalent circuit. This is the equivalent circuit. Let a current IR is following the equivalent resistance. This is the resistance current. This is the capacitor current. So this is the current due to resistance, here current due to capacitance. Okay, next, here IR on the x-axis we take the voltage, on the y-axis we take the current. So here IR will be in the direction of V. IR will be in the direction of V, I suffix C is in the I. So here I is the 90 degrees to V. So here IR, current resistance, is in the direction of voltage. Current capacitance, current due to capacitance is the direction of the 90 degrees to V. 90 degrees to V, that is the I. That is the I. The resultant of IC, and IR. The resultant of IC and IR is the I. Between angle IC and IR is the theta. Here theta is the loss angle. Here theta is the loss angle. The tangent of this angle is given by the tangent of this angle. Tangent means tan theta, tangent theta. So the tan theta is called as a loss tangent angle. Loss tangent angle. This is the tan theta. This is the tan theta. The dielectric loss is the V I suffix R. From the diagram, this is the theta, this is the 90 minus theta, this is the 90 minus theta, this is the right angle triangle, this is the right angle triangle. So this is the IR, this is the hypotenuse is the high. So here cos 90 minus theta, this is the theta, here this is the angle, cos 90 minus theta equals to adjacent side upon hypotenuse. Cos 90 minus theta, adjacent side is the I suffix R, hypotenuse is the I. So here IR equals to I cos 90 minus theta. Cos 90 minus theta. So then so this value is substituted in the above equation. So the dielectric loss is equals to V I cos 90 minus theta. Cos 90 minus theta. So then cos 90 minus theta equals to sin theta. Dielectric loss equals to V I sin theta. This is the first equation. This is the first equation. From diagram, cos theta equals to adjacent side upon hypotenuse. Adjacent side of the theta is the I suffix C, hypotenuse is the I. Then I equals to then I suffix C equals to I cos theta. Then I equals to IC upon cos theta. This is the second equation. From 1 and 2 equations, the dielectric loss is equals to V I means I suffix C upon cos theta into sin theta. Then the dielectric loss is equals to V I suffix C into sin theta upon cos theta. So the dielectric loss equals to V I suffix C into tan theta. So this is the dielectric loss. This is the dielectric loss. This is the dielectric loss. This is the third equation. This is the third equation. But already we know that I suffix C equals to, so current due to capacitance equals to voltage upon XC. Voltage upon XC. So in the this formula is in final year, 5th semester, 5A paper. The XC is the reactance of capacitor. Here V is the voltage, XC is the reactance of capacitor. So this value is already, we know that current due to capacitor equals to voltage upon reactance of capacitor. Then already we know that XC, the reactance of capacitance, equals to 1 upon 2 pi Fc. 2 pi Fc. Here F is the frequency, C is the capacitor. F is the frequency, C is the capacitor. Okay, from the dielectric loss, finally the dielectric loss, V is the V. Okay, IC is the V upon XC into tan theta. Okay, the dielectric loss is equals to V into V square upon XC into tan theta. The dielectric loss V square. What is the XC? XC is the 1 upon 2 pi Fc into tan theta. The dielectric loss is equals to V square. So this value is the 2 pi Fc into tan theta. This equation represents the dielectric loss or power loss. V square into 2 pi Fc into tan theta.